Hey everyone, welcome back to the College Algebra playlist. In the previous video, we took a look at factoring, which is the process of taking terms and turning them into factors. Alright, we factored a special type of polynomial, right? Trinomials with a leading coefficient of 1. Alright, so in this video we want to generalize. We want to factor bigger and uglier polynomial expressions. Alright, to do that, we need to use something called the GCF, which stands for greatest common factor. So let's dive in. Okay, here we go. Before we talk about the GCF of polynomial expressions, I want to start simply and just talk about numbers. Okay, the GCF of numbers. The greatest common factor of two numbers is the largest number that divides evenly into both numbers. Okay, that's how the GCF is defined. Let's look at a concrete example and find the GCF. All right, find the GCF of 16 and 20. To do this, we're going to make two lists. Okay, lists of factors of 16 and factors of 20. Okay, so you can multiply these numbers together to get 16, and down here you can multiply these numbers together to get 20. All right, we're looking for the greatest common factor, which is the highest number that occurs in both lists. Okay, so it's common to both lists. The factor is 4. This is the highest number that appears in both lists. So the GCF of 16 and 20 is 4. All right, we can extend this to 3 or more numbers. All right, the GCF of 3 or more numbers is the largest number that divides evenly into all numbers. All right. Here we're asked to find the GCF of 24, 36, and 60. Okay, so we're going to do the same thing, right? We're going to make lists of factors of each number, okay? And then look for the biggest number that occurs in all three lists. All right, in this case, the biggest number is 12. Okay, so the GCF of these three numbers is 12. Next, let's look at variables raised to different powers. All right, here I'm asked to find the GCF of x cubed and x to the 6. All right, let's do the same thing, right? Let's make lists of factors of each of these things. All right, so these are just variables raised to a bunch of different powers. All right, what's the highest quantity that occurs in both lists? It's x cubed. Okay, this is the biggest factor that occurs in both lists. Okay, so the GCF is x cubed. And this is how it's always going to work out. All right, the GCF of a set of expressions in the form x to the n will always be the variable raised to the exponent of lowest degree. Okay, so we're looking for the lowest value of n. All right, x to the n is the GCF. All right, here we're asked to find the GCF of x squared, x to the 5th, and x to the 8th. All right, instead of making lists for all three of these, let's use the rule that we just learned. And let's just say the GCF is x squared, right? Because 2 is the lowest power that occurs. All right. So now let's put these things together, right? We found the GCF of numbers and we found the GCF of variables. All right. So the GCF of polynomials, right, which is a mixture of numbers and variables, is the largest polynomial that divides evenly into the polynomials. Okay. So here we're asked to find the GCF of these three polynomials. Okay. To do this, we're first going to look at the numbers, right? The coefficients in front of these variables. Okay, we have 6, 45, and 21. All right. The GCF of those three numbers is 3. Okay. Then we look at the x's, right? We have x cubed, x squared, and x to the 1. Okay, so the GCF of those three variables to powers, right, is just x to the 1, right? 1 is the lowest power that occurs. Next, we look at the y's, right? We have y cubed, y squared, and y to the 1. So the GCF of those three things is y to the 1. All right. Then we combine these results. All right, we combine them in a product, right? The GCF of the numbers in blue here, we have 3. The GCF of the x's, x in red we have. And then we have the GCF of the green right? So we have y tacked onto the end here. All right, so the GCF is 3xy. The GCF of these three things in black is 3xy. Okay? Up next, we're going to take a look at factoring polynomial expressions. Okay? In the previous video, we looked at special polynomials, right? Polynomials with a leading coefficient of 1, right? Trinomials with a leading coefficient of 1. Here, we're going to look at a 5-step process for factoring polynomial expressions. Okay? We identify the GCF of the coefficients, we identify the GCF of the variables, and then we put those together, right? We combine them in a product to find the GCF of the polynomial expression. Okay? Then we determine what the GCF needs to be multiplied by to obtain each term in the expression. Okay, and finally, we write the factored expression as the product of the GCF and the sum of the terms we need to multiply by. Okay, so let's do this for a concrete example. Here I have the same three expressions from this screen here, okay, but I'm adding them up, okay? I'm adding them up as one big polynomial expression, okay? We already found that the GCF is 3xy, okay, so the first three steps in this case are done for us, okay? The GCF is 3xy, okay? So let me show you what we're going to do with this 3xy. Okay, we're going to factor it out of each piece. What do I mean by that? Let me show you. The distributive property says that when we have a times b plus c plus d, right, we can distribute this a to each piece. Right, we get ab plus ac plus ad. All right. So this is what the distributive property tells us is true. Okay. What I want to do next, though, is I want to swap the left and right hand sides of this equation. Right? We're reading it from left to right like it's a sentence in English. Okay? We have three terms here, and we're writing it in its factored form, right? As two factors, a times this thing here. Okay? That's exactly what I want to do in black up here, right? I want to take these three terms and write it as a product, 3xy times something. Okay? So we just need to figure out what goes in each blank here. All right? So first, ask yourself, 3xy times what equals 6x cubed y cubed? The answer is 2x squared y squared. Okay? Next, we ask 3xy times what equals this? And the answer is 15xy. Okay? Lastly, we ask 3xy times what equals 21xy? And the answer is 7. Okay? So this is my final answer, right? I took three terms and I turned it into two factors. All right? So we pulled the GCF out of each piece, right, to get this factored expression. All right, let's do one more example. Here I'm asked to factor this thing. All right, so the first step is to find the GCF of the numbers, right, of the coefficients. All right, the GCF of these three numbers is 18. All right, we can make lists and show the factors of each of the numbers and then spot 18 as the biggest number that occurs in each list, but I'm omitting that for the sake of brevity. Okay, next we need to look at the j's. We have j to the fourth, j cubed, and j squared. The lowest power that occurs is 2. So I have j squared. Next we look at the k's, right? We have k squared, k cubed, and k to the fourth. The lowest power that occurs is 2, so k squared is included in my GCF. Okay? This is the GCF of this entire expression. All right? So let's factor that out and fill in these blanks. All right? 18j squared k squared times what equals 36j to the fourth times k squared? The answer is 2j squared. Next, we ask 18j squared k squared times what equals this? And the answer is negative jk. Okay? Lastly, we ask in green here, 18j squared times k squared times what equals 54j squared k to the fourth? The answer is 3k squared. Okay? So this is my final answer. And if we want, we can actually distribute this to each piece to see if we end up with this. Okay, we can check our work. I'm going to omit the check here for the sake of brevity and just say that this is my final answer. All right, check it and you can see for yourself that it's right. All right. That does it for this video. Thank you for watching, and like and subscribe.